using a Visual Studio Code. This is an IDE that you can download if you haven't already, online, free of charge. It's very easy to set up. You can, or you may use other IDEs online by simply doing a Google search, Python IDE online. You can use them as well. If you have other IDEs, the effect should be pretty much the same. So without further ado, I'm gonna bring up a new Python file. So first thing I need to do is to save this file. Let's say test.py. Okay, now this is fully aligned. I already have Python lint installed, which is a formatted tool that allows you to see the syntax error, if any, while you debug and write code in IDE. Okay, so initially, let me go through a number of exercises starting with functions. We sort of went through this in the class. There are various different types of functions. There are built-in functions as well. So when I say built-in function, these functions are already available inside your IDE as part of your download package. So we have maximum, minimum, maybe len. So maximum is to find the biggest value item in a list, or it could be the maximum value inside a collection of numbers. Minimum is the opposite of max. Length, in this case, is the number of characters inside a particular string. For example, string, if we recall, this is a collection of characters. So let me just go through a number of examples here. Forget about these. Let's say we have 2 lines of code here. The maximum of hello world, in this case, is W. Why? Because we call that hello world. This is encapsulated in the double quoted string. A string is a collection of characters, and max in this case is simply just finding the maximum character value. In this case, W carries the maximum character value. This is all part of the ASCII. So I'm just gonna take this. So ASCII table, you will see a whole bunch of character values associated with it, and that is the, sorry. So Python uses the pound signs here for comment. So let's just run this. Minimum is the opposite of max, right? So as you can see, max value gives a W, and minimum value gives H. Let's try the other building function called length. So this one counts the number of characters. So let me just comment these out and simply just run this. As you can see on the bottom, I have my terminals ready, so I'm just going to bring it up there so you can see it closely. Once I run it, I get 11. So 11 stands for the number of characters that's in here, okay? Including space. So if I were to add a couple spaces, let's say 3 spaces, 4, and run this again, and you're going to see the result changing, okay? So, so this is the building function called length. We can also, and we've done this before, I'm just going to cut and paste a slew of statement here using a couple of building functions called print, int, float, and stir. So let's go through what each of these is. We know what print is. So print prints the entire payload inside this parentheses into your console. We know that. Integer is a conversion tool. So this conversion function simply says it. You can even hover over it and see it. This is where the Python lint is coming into play. It's very useful. It has documentations on what each of these functions is doing. So in this case, int converts, as we went through this in class, a number of string to an integer. And notice that the string has to be numeric string. So if I add an A here, it won't work, okay? So it has to be a numeric string. a string that looks like a number. Anyway, we can also convert a true number into a string using an str function. So in this case, both in and str plus print, these are all built-in functions. So let me, before I run this, maybe I just run these 3 lines, right? And we call that print with nothing inside. This prints an empty line, right? Blank line. It introduces what's called a line break at the command line. So let me just run this, and you can see the string conversion as well as the integer conversion work. Plus, I added a blank line underneath it. I can do another blank line and simply run it, and you can see that there are 2 empty lines here. Okay. So let me just comment this out and uncomment these. So what are we looking at here? Now, if you were to convert a number to a string, and this number is a decimal number, which is a float, you're not going to get all of the decimals. So in this case, you get truncated value called 3. Flow is the same thing too. Once you convert integer to flow, you're adding some decimals. So let's just run this before we move on to the next one. And as you can see, indeed, what happened was your 3.99, you got truncated, leaving you with the integer and no decimal. Same thing with flow, now with the additional of 0 at the end. So typically, this flow has twice the amount of space as an integer in memory. Float holds up to about 15, 16, actually no, 7 or 8 decimals after integer. Okay, so let me just uncomment this again. And now you can see, let's just run this. You should be able to see the same conversion as well, because 3.14 is a numeric string, and we can convert it into its float representation. Integer representation is fine too, except integer is going to get you less amount of space, giving you the integer portion of the number, but float gives you the entirety of it. Same thing with 5.67. Once you convert it into a string, you get exactly what it says. So as we can see, both of these carried out exactly what we need. So this is, let me see if there's some more. Okay, so let me just get rid of all of the lines here. Sometimes you see something like this, import, right? Import, I say, nah. And then you can run a whole bunch of stuff here, right? A whole bunch of stuff. Whole bunch of stuff here. Now, what does import mean? Well, recall that they are many libraries or functions that are part of your Python installations, but at runtime, meaning when you load your Python IDEs, you don't get to see or use these libraries unless you tell the program that you're loading it, right? That you're using it. So if you don't do that, let's say if you don't do import math, then you won't have math functionalities as part of that library import. So what do? You write import, right? So what import math really is doing is just importing a whole bunch of library headers, telling the program that you are talking about the use of this library. So please make sure that you look into that section of the library as far as its runtime is concerned. So if I would do something like some of the very basic mathematical library functions that we see are square root, right? So you can simply write something to the effect of this. So effectively what happens here is you're calling the math libraries and inside our math class, so to speak. And we want to invoke the square root function inside the math class. And this class is part of the math libraries, right? And you want a square root of 4. So let's just run this. Right, now you see the square root of 4 is 2. If you don't, however, use math. I just say if you just want a square root. And notice that links capture the errors here right away, so you can see what it's missing. But if you want to run it anyway, you're going to see name square is not defined, right? Because it was never part of the your original Python installation. So you have to ensure that you know the namespace for this class or function here is called out. Another way of writing this, sometimes people do that a lot, is they say from math import square. So this is not a way of saying that you want this particular function inside this class be null, right? So instead of writing math dot square, you can get rid of the math because the program already knows because you just told them so, right? And you were to run this, it will give you the same thing. So both way of writing is totally fine. If you were to, the rule of thumb is if you were to use a whole bunch of function inside a particular you know math collections or libraries, you would want to probably just do something like this. Is that no? I'm sorry. You would want to do the first approach to ensure that you have the max amount of flexibility, right? But if you just want to use this specifically, in this case, a square root inside of math, and you want to use square root a lot of times, let's say 4 or 5 times, let me just maybe write another one here. You don't want to keep writing math.square. In that case, you can pretty much you know, just reuse the square root without having math by saying from math import square. So these are some of the best practices that you see around. A lot of times, you know, I'll give you another example of an import. So let's say if you want to create a shuffling effect, you want to randomize your particular choice. Let's say if we have a list of strings, which is a collection of strings. So this is in other programming languages we call it an array. Python has a way of saying when you have a one-dimensional array, you can create what's called a list. A list contains a collection of things. In this case, these things are strings, right? Let's say if you have that, and you want to print out a random selection inside any of these. In that case, you will want to say random.choice. So random is a library, right, or class in some sense. And when you dot something, this means that you are invoking a function inside a random. And in this case, the argument you will want to pass in will be this entire string list. So what this choice would do is select a random entry inside this list, giving you something completely random. So if we were to print this, you would see, let me just build this, start this over, reinitialize it. Oh, because I didn't save it, sorry. So now you can see that the random choice calls out Jose, but if I run it again, you get John. If I run this again, you get Jane. So every single one of these selection choices is random. So random.choice gives you that. And of course, if you want to keep reusing choice functions, you don't need to write import random. You can simply just write from random import choice. In this case, we can get rid of this, right? We get rid of this random. And simply run it again. You get the same effect. Keep running it. You get random choices. These choice, what we call randomizer, is not true random. So what do I mean by that? So in programming languages, on your computer especially, it doesn't matter if you have Windows, Mac, pseudo-random generators generate something that is pseudo. So if you, in this case, you have 1, 2, 3, 4, 5, you have 5 collections here. A pseudo-random generator, in this case, what this choice is, gives you a semi-random. And what does that mean? That means out of maybe 1 to million times, if you were to repeat this randomizer, not many times, you're going to see patterns. So that is unfortunate, but this is a pseudo-random generator or a concept is beyond the scope of this class. But for a small amount of collection, it's safe to say that these choices will be relatively random. So that's what I wanted to cover, pretty much on your building functions, right? So in class, we also kind of went through a number of different types of functions. Let's say, for example, void functions. So what is a void function? A void function is any function implementation that does not return anything at all. So what did I mean by that? Now, for example, if we write def, as you know, def starts is a definition for a function. So if we just say print message, right? You don't want to use print because print is already reserved keyword. Let's say print message, which is a totally benign function naming conventions. We let's say if you want to print a number of things, hello and world. Now notice that this function does not return anything at all, which is totally fine. In that case, when I say it does not return anything, it does not return, right? Something, let's say, X, Y, Z. It does not return anything. So this function does not return anything. What does it do? Well, it brings the message to the screen, right? So you can write something like this. Now notice that the function definition convention calls for def keyword in front, plus the name of the function, plus the parentheses. And since there are no parameters in there, we leave it empty, and plus a colon. And notice that the forthcoming lines, line 3 and line 4, these two lines have to be indented once to ensure that whatever you indented here is part of that function. In some languages, they use curly braces like this, right, to put print inside these curly braces, but Python does not have that convention. Okay, so it's absolutely very important for you to understand. You don't want to use spaces. Okay, you want to use indentations. In Python lint, it's very nice because it shows you that kind of indentation. You see this gray line underneath it to indicate the position of your sentences or your statements. So if we were to run this, we'll get hello world here. Now, let's say if you made a mistake. Let's say if you indent one of them twice. So what does that mean? Well, this is not correct because what happens is you're effectively pushing hello to the next scope. So you're creating something that is nested inside print's message here. This is not good because, and you can see Python lint gives you this error right there, and you can simply mouse over and see what's going on. But let's say if you were to ignore that completely and just run it, you'll see, and this is a very commonly seen error called indentation error. Unindent does not match any other indentation level. So you gotta be careful about the indentations. And if you want to do something that is nested, let's say if x equal 0, right? Equals 0, you have to do something like this. Then print this, right? Then you can create what's called nested or internal indentations. You can simply print this, and this is totally okay. Okay, so this is where indentation is used, right? If there's nothing that you need to do to create some sort of a nested inclusions inside your function, don't make sure you only have one indent. Okay, so that's what I want to say about void function. Let me just maybe create a couple of them. Let's say if you and this is all your exercises, right? And make sure that you you go through them and let me know if you have any question. Let's say we have another void function. This is the addition function that calls for 2 parameters. And if you were to create, let's say, a statement here calling for addition of something, you can simply pass 2 arguments. So these 1 and 2 are called arguments, but in the form of a function here, these are called parameters. So you were to pass in 1 and 2 as arguments into this addition that has 2 parameters in there. What it does is it creates a sum, right? a local variable. This is local to this function, and print it. So if you run the code, sorry, I have to save. Always make sure you save and run it. You see that the sum of first number and second number is 3. So this is one example, another example of a void function. Let me maybe go through maybe another example where you create a function with multiple types. So both first num and second num in this example are integers. What if you would maybe create another function that takes multiple types? So in this case, first name is a string, last name is a string, but age is a number, right? So notice what I'm doing here is I'm creating a string concatenation. This string concatenation is very simple. It converts the first name, right, to a string, second name to a string, and an age here into a string. So age is a numeric, is a number, right? So what am I doing here? I already know that the first argument I'm passing in is already a string. Why am I converting this to a string? Well, this is just to be on the safe side, okay? So because you want to know that you never know what user is going to pass in, since Python is type conversion is implicit. You don't specify that first name is string. So in some other languages, they put something like this. So in your function definition, you'll see the type of the parameter in it. But since Python doesn't do that, it allows you to implicitly pass in a data type. You want to be super careful, as your print full name is always going to be used. You want to do a conversion, even though you know in this one example, John, Doe, both are string. You shouldn't have any problem like that. So if you run this whole thing, you will get the entire concatenated string once and get it printed to the screen. Okay. So this is one example of creating a void function with multiple data types. There's a whole bunch of other ways of creating a function. Sometimes you can pass in a function with a default value. So this happens sometimes when you, let's say, if you want to, let me just use another one. Say, no, let me just use the same one. If the first name doesn't have an entry, let's say, when arguing that let me just say, let's print age here. Let's modify this a little bit. So in this case, what I'm doing here is I create a function, and this function has one parameter with a default value of 0. What does that mean? That means this function can also be called when there is no arguments. So a default parameter value means if the parameters do not get passed in, or a function call does not have any arguments in it, h is defaulted to 0. All right, this happens a lot when, let's say, if you create a function and you know most of the time the default value of something is always going to be that. One example is calculating the area of a circle, and you know pi, right, which is involved in the calculation of the area of the circle by multiplying it by square root by a square of your radius. Pi is always 3.14, right? So you can pretty much just say that by default pi is 3.14, so you don't have to specify every single time, or you can create a local variable for it. So this is another example of creating a void function with a default value in it. Now there are multiple ways to write this. A default value has to be, for example, the last couple of variables. So if you have something like first, last. You want to make sure that the default value is always at the end. Okay, and then you can have multiple default. Let's say h2, or you can say 10-year equals 10 or something like that. So make sure that all of these defaults are at the end. You want to specify your unknown parameters or parameters with any variables data at the front. Now, the coverage for, or the reason behind this is kind of beyond the scope of this class, but just know that you can define a function with a default value. Okay, so that is what I want to say about pretty much about void functions. So let's take a look at a function, for example, that returns something, right? So we sort of cover this in class. A lot of times you can define a function that returns, let's say if there's a function that returns, for example, a string called fantastic. So simply what you do is just write this out and call it. So I'm going to run this. See that in this case, return message returns be fantastic, right? If I were to simply just run this, it does not print anything at all. Why? Well, because return, even though it returns a string, it does not print to the console, right? So in order to show it down there in the console, you have to make sure that you are printing it to the screen. So what I'm doing here is I'm simply just wrapping this function with a print statement, so you can see that this is printed. Or another way of doing this is you can say return val, right? Return value from this is that, and then you can print it to the screen that way. So there's multiple ways of kind of going about it. If you want to have it done, display to the screen. So this is one example of a function that returns. And of course, you can write a function that returns any data type. So in this case, I can simply say, I want to return a number. I say return 1, right? So Python doesn't really care what the type of return is or any type of input, what their data types are. You can simply just write this in and print it that way. So this is another example of a function that returns something. So I'm going to show you maybe another variation of this. So in this case, you have both returns. And what does that mean? Is this one even valid? No. And Python lib pretty much tells you the reason, right? Because what happens is once you return from a function, so return basically says return your flow of control back to the caller. So what is my caller? I'm going to write my caller. My caller in this case is line 5, right? So remember the evaluation of a Python code starts from the very top, line 1 all the way down to line 5. So when line 5 is called, it knows the existence of this return message. So it goes through it and run it. So by the time 5 is called, it goes into 1, it goes into 2, and 2 says return. So the flow of control is immediately back to number 5 again. So number 3 is never reached. You can run this, but you're not going to get anything. Let's just say print this guy, right? So I want to print whatever is there. Be fantastic is printed because what happens is as soon as your program evaluates line 2 returns. So line 3 is never reached. Line 2 returns to this, right? Line 5 again. And line 5 says print this, right? So therefore it prints. This is what happens when you have multiple returns. And obviously having multiple returns in the function is syntactically incorrect. It should be banned. So just make sure that you do that. Let's say if you made not a mistake and you write something like this. And this is very curious is because what happens is you have one return, right? And then you have this comma. So I don't know what this comma is. Supposedly you're thinking maybe you can return multiple messages or multiple strings from this function. You're wrong. You can't do that. So what happens is you would run it just like before with this. So what happens is what you have here is a value returning function with no parameters and returning multiple values. Recall that you can't just get your the very first parameters out. In this case, you're getting what's called a pair. So this is a pair returning from this code. If you want to capture the individual value inside, you can do something like this. So calling the function, and since it returns two strings, you can say the first one is this, the second one is that, and you can capture both of them and print them out. So in this case, let me just print the very first one out, and you can see it'd be fantastic. And if I want, I can create another one, message 2. In this case, I'll be printing both of them, okay? So this is kind of a way of capturing multiple returns from a function. So I can go pretty much on and on about creating a function that returns something. There is plenty of an example in your chapter 4 -4 called value returning function.txt. Recall you can go into these references to see for yourself. I would advise you, if you can, to run through all of these examples and let me know if you have questions about them. It is imperative that you understand how function is used, why they are used, and the fact that you can have various different types of function and tools that you disposal helps you become a better programmer. And this is what we do. A lot of times at home we practice, right? You look at someone else's an example, and there are plenty of examples, more than 4 or 5, 6 hours worth of videos for you. At some point, you should go through all of them, and don't just cut and paste. I did some cut and paste here to facilitate my learning, my lecturing, teaching here. So you don't sit me here and typing these individual one characters at a time. But at home, you should be typing those in by hand. I would not recommend doing cut and paste, especially at this level, at the introductory level, because oftentimes you become adroit at cutting and pasting, and that inevitably didn't get your mind set on the concept, so you don't remember them, and this is not a good way of learning in the very beginning. Okay, so let me just recap kind of everything we talked about so far. We talked about building functions. You don't have to memorize these building functions. A lot of times you can do a search on a specific functions, and they'll tell you have to include certain libraries, right? Like statistics, math, random. These are just some of the examples of computation libraries that you see in Python. We also talked about void function, a function that does not return. And of course, we talked about functions that return something. So these are sort of various different types of functions. And of course, when we start defining our function, these are user defined functions. So you can pretty much define anything by any signatures you like. As a general rule of thumb, and let me just use this example here. So this is really philosophical. The naming of your function, you want to make sure it doesn't start with a number, right? And if you have Python Lint installed, you'll see that this is totally not good. It'll turn everything into red. The other one is I like using camel casing. quite a bit. So this means separating all of your spaces and constructing an entire sentence using uppercase letters, right? Return message from here. So as you can see, both H and F here are capitalized. Some people don't like to use that. They use underscore. Let's say from here. I really don't like this because this actually makes your function naming much longer than really necessary, but it's totally up to you. The other thing is make sure that the user variable is not X, Y, Z, but something that is a little more human readable. You can say something to the effect of message, username, right? Password, something like that, right? So it's a little more descriptive. So these are some of the best practices you have. And of course, on top of your function, you should definitely style it. We do this a lot, even with my developers at work, is to specify, to write something down about this function. I say, this function is for returning, for computing, for logging user in and displaying message from service for login, right? Something to that effect. And you can also use multi-line to document and style your code. So developers in the future who takes over your code on legacy system sees your documentation and knows exactly what this function is for, right? I'm just gonna write some funny stuff here to make sure that this is compiled, right? And another best practices that you do is as you construct your functions and your code, to save them and try to run them as frequently as you can, so that you can see the efficacy of your code. You don't want to wait until maybe 30 minutes, right, with maybe 20 lines, 40 lines, or even hundreds of lines of code and do a test. That's not good because a lot of times you've gone past what errors can tell you, and it takes a long time for you to go back and debug your code, find out what it is. So do this incrementally, right? Iteratively and as frequently as possible. This helps with your code creation. So that's what I wanted to say about function for now, including best practices.